Hi, this is T.H. Culhane for Solar Cities and Envisage Mercy, the Environmental Sustainability and Justice League at Mercy College. And I want to explain a wonderful discovery we've made here today and how it will impact the future of small-scale biogas. It turns out that in this particular village, where they're growing a lot of great plants in this basically more or less hydroponic style, if you like. It uses soil, but it's elevated or raised bed gardening and is very amenable to hydroponics. They seem to all have these raised tinacos, these raised water tanks that are used solely for irrigating the vegetables. Now, why this is great for the small biogas world is because this can be both a biogas system and a fertilizing system at the same time. In the hydroponic and aeroponic world, we know that there's no need for fresh water. We use fertilizing water, a liquid compost. And instead of putting clear water in here, which sometimes has chlorine that's it's bad for the plants, this could be filled with biofertilizer all the time, which could be then irrigating constantly through drip irrigation. The way that works, and what we're experimenting with at the Fundación Haciendas de Mundo Maya in Mérida right now, is you take a simple tank like this and you don't make any penetrations at all, don't cut the tank at all. What we do instead is we put our feeding pipe in the top of the tank and we put our fertilizer outflow also in the tank, and then we put a valve for the gas production. Then we put nuts and bolts with wing nuts. So bolts underneath with wing nuts and rubber or silicone, and then we seal this tightly so that it is gas, air, water tight. And then this acts as an anaerobic digestion chamber, a fermentation chamber, without damaging the tank in any way. Because the food is introduced from the top and water rises to its own level, if the fertilizer pipe is also coming out of the top of this, when you put an overspill of food and water in, and you can also put animal waste if you like, then what will rise up is the liquid portion. The solids will stay down at the bottom. Here the problem is you need clear water in these tanks, because if you don't have clear water, the solids here would clog up this pipe and clog up the irrigation. But in our system, we would only use this as a drain. We wouldn't use this for irrigation, and instead we would take our fertilizer out of the top, and so the sediment would fall, and only a very light, nutrient-rich fluid would overspill each time you fed it, would overspill and irrigate the garden in drip irrigation. Meanwhile, you build up a pressure of gas in here with the valve that you could use to fill a gas balloon, like we do with the Pusheen balloons, the PVC bags that we're using in all our systems in the US right now, or a truck inner tube. We've also been using those, a 60-liter inner tube. And so you get yourself a biodigester and a biofertilizer and a storage without changing anything in the local system. So as far as the local people are concerned, there's no increased investment other than putting the 3 tubes inside here, which is very minimal in cost. So it seems like this is ready-made for the solution we're going to try. We're really excited to see that here's a situation where it will require very little convincing of people, because it doesn't change the basic structure, it only adds to it. Thanks.